Now this looks like a scary problem. We've got two huge logs with some weird square root expressions inside them, but it's actually not that bad so long as we remember this log rule over here. If we add two logs of the same base, we multiply their arguments. M and N are the arguments, and they get multiplied here in this log. So here we have two logs being added together. We're going to multiply their arguments because these are of the same base, base 4. So we end up with log base 4 of x minus the square root of x squared minus 8 times x plus the square root of x squared minus 8. Now that's a lot to multiply, so I'm going to kind of just write it here for starters, but we will clean this up in a second. We're going to abuse some rule that we learned back in algebra. We know that anytime I have the expression a minus b times a plus b, that simply comes out to be a squared minus b squared. Well, that's exactly what I have here. I have some letter, in this case just x, here to start. Here I have minus some gross thing, and then I have plus some gross thing. That's exactly this form here. So we're going to use that form to go ahead and say this simplifies to x times x is x squared. We don't need to bother with a middle term. There is no 2ab term, as we usually see when we square some sort of binomial. And then we have a minus this guy squared. Well, when I square the square root of x squared minus 8, I get x squared minus 8. Now, something to be really careful about is I've made a mistake deliberately. I want you guys to see if you can spot it. When I took negative square root of x squared minus 8 times negative x squared, or times positive square root of x squared minus 8, I got x squared minus 8, right? That makes sense. I have square root of x squared minus 8 times square root of x squared minus 8. I just get x squared minus 8. That's all fine and dandy. One thing to remember though is that this is going to be a negative in front of this because one's a negative and one's a positive. So what have I done wrong? The one thing I've done wrong is the most common mistake ever made in any sort of calculus or pre-calculus class is forgetting to put parentheses where they belong. So there should be a parentheses around this expression x squared minus 8 because this negative that we see sitting out in front of this b squared needs to be distributed not just to the x squared but also to the negative 8. That's super important. If you forget these parentheses, the whole problem is wrong. So now that I've got these parentheses written, I can go ahead and simplify the inside. X squared minus x squared, these cancel, and I have negative 8, so that gives me log base 4 of 8. This answer is fine as it is. We can do a couple things to clean this up. We could say, I don't like the idea that they do this on an answer choice, but they can also do this, right? This is log 1 plus log base 4 of 2. And you're like, how in the world did you get that? What I've done is I've gone ahead and abused this rule in pink again. What I've done is I've decided to rewrite log base, let's erase this a little bit. What I've done is rewrite log base 4 of 8 as log base 4 of 2 times 4. I think we can agree that 8 is 2 times 4, right? But I can split that going back from this rule to this rule and break it apart into two logs. I can say this is log base 4 of 2 plus log base 4 of 4. And then you might say, well, how do I still go from here to here? This is the last rule I'll write up here. Anytime you have log base a of a, that's 1. So log base 2 of 2, that's 1. Log base 7 of 7, that's 1. Log base pi of pi, that's 1. Log base 1 million of 1 million, that's 1. So here we have log base 4 of 4, and that is 1. So you see how your final answer ends up being 1 plus log base 4 of 2. Seems insane to me because there's actually easier ways to write this, but sometimes you run into crazy looking expressions like that.